Hello, back again. I want you to do the same thing, slope-intercept form. M is the slope, B is the y-intercept. But you got to solve for y, and on this problem, y is not solved for. Y is not by itself. So, what do we have to do to solve for y? What do we have to do to get y by itself? Well, we have to get rid of this 3x. Now, some people are going to say, oh, you add 3x. No, you don't. That's a negative 3y. See, what's the sign in front of the 3x? It's a positive, so in order to get rid of positive 3x, you subtract 3x on both sides. Rewrite. 3x minus 3x is 0. It's not x, it's not 1. And we're going to write it with the x first, then the y-intercept. So it's negative 3x, and that's a plus 12. Now, the y is still not by itself. So what we're going to do is divide both sides by negative 3, because that's a multiplication. It's not an addition, it's a multiplication. So divide by negative 3. But what I do on one side of the equation, I do on the other. Negative 3 divided by negative 3 is 1, and then with a y left over. So we're just going to write y equals, here we got one denominator and two numerators. It's that little trick I showed you where you take each numerator and divide it by the denominator. So we're going to do this numerator and denominator first. Negative 3 divided by negative 3 is 1 with an x left over. 12 divided by negative 3, that's a positive divided by a negative, which is a negative, and 12 divided by 3 is 4. So my graph is x subtract 4. Oh, I love this example. It's perfect, actually. It covers more than I wanted to. What's my y-intercept? Because that's the first one that I deal with. My y-intercept is the number by itself without an x. And that's negative 4. So I start at the origin and I go down 4. 1, 2, 3, 4. Now, my slope is a little difficult to ascertain at this point, but it's actually not that bad. What's the number in front of x even though you don't see it? Ax is the same as 1x. And when I said you don't see a denominator, you automatically put down 1. If you don't see a denominator with the, combined with the x. So my rise is 1 over 1. So my rise is 1, my run is 1. So I'm going to go up 1. Over 1. Yeah, let's just keep doing it for fun. Up 1, over 1, up 1, over 1, and so on and so forth. This is a discrete function because it's nice little discrete points. It's not continuous until I draw a line through it and then extend arrows on both sides. Now it's a continuous function. What's the domain? What's the range? How far will it go this way? If this graph keeps going forever here and forever here, what x values can I keep plugging in? Negative infinity to infinity. My domain is my x values. So I can go from negative infinity to positive infinity. And my range is how far down and how far up it goes. Well, this is going to go down forever, and it's going to go up forever too. It's not going to go up. Yes, it will. It'll go up slanted, but it's still going up and up and up and up. There you go. I'm going to do the parent function of y-intercept and see where it goes from there. After that, I'm thinking direct variation, and we have a pretty good concept, grasp of linear functions. With that said, have a good day for now.